Hey guys, how you doing? It's Shalajora here again, back with another video from Be a Gem at GCSE Chem, and today we're doing section C4.5, which is called Atom Economy. And so it's a really interesting topic. It's only for triple science students only, not for people studying combined science. So yeah, I'll go through that. Also, just before we start, I want to mention a couple of things. So basically, in the last video, I made a video for Year 11 students on why, because Year 11 students obviously received their GCSE results yesterday. So I made a video on why you should pick A-level chemistry. I forgot to mention two other things, which I've written now in the comments in the last section's video, in last lesson. Yesterday's video, not last lesson, we didn't do a lesson, but in yesterday's video is that I didn't really talk about the jobs. So basically I said chemistry was a facilitating subject. A-level chemistry is a facilitating subject, which is true, so it's highly regarded by, highly respected by universities. And that basically means that there are many careers you can go into with A-level chemistry. So, the careers which require A-level chemistry as a must, so it's essential to have A-level chemistry for the following careers. Like if you want to go into medicine, dentistry, or if you want to become a vet, you need A-level chemistry. Like it's a must. If you want to do these kind of courses, if you want to go into those professions. But even like A-level chemistry is useful but not essential, but it's still very useful for things like engineering. Obviously chemical engineering would require A-level chemistry as well, but if you want to do other types of engineering that may not be chemistry related, or computer science or something, anything in science and technology, really, it would be really helpful to have A-level chemistry in those kind of areas as well. So that was one thing. And also also if you want to actually see if A-level chemistry is right for you, have a bit of a feel for it before you start the course, before you actually start picking it. Even though I think in the first 3 weeks you're allowed to change, 4 weeks in the first month you're allowed to change your options. If you want to kind of see if A-level chemistry is right for you, then I'd suggest looking at the following AS topics, so Year 12 topics. So that's electron configurations, electron configurations, which are the A-level standard. So type that in Google and you'll find that. And then ionization energy is another topic that you might want to have a look at. And also there's another topic called nomenclature of organic compounds, and nomenclature just means naming of organic compounds, and that's in the organic chemistry. And then the electron configurations and ionization energies, that's all in physical chemistry. So I'm pretty sure they're both in physical chemistry. I might be wrong, but basically just search those topics up, see if you like them, and that should hopefully help you decide if you like. That should hopefully help you in your decision of when is A-level chemistry right for you, should you pick it, and stuff like that. But hopefully my video was helpful yesterday as well. So these were the points I kind of missed from yesterday's video. And also I would like to congratulate obviously everyone who got their results yesterday. I hope you all did well, and in particular I have a friend on WhatsApp. He got his GCSE results yesterday. He did really well, including a grade 9 in physics, so I just wanted to shout him out there. Well done to you, man. Annobai, or his name's Anime, but I call him Annobai, Anno brother, but Bai means brother, but yeah. So so that's congratulations to you. And so that was basically my introduction. I haven't been able to put the links up from C3.2 to C4.4, and also the should you take A-level chemistry, why should you take A-level chemistry video. I haven't been able to put that up, the link to that up on my website as well. I'll try and do it all by today, but we're doing C4.5 Atom Economy, and the book I'm using is obviously this one. It's the AQA GCSE Chemistry Caboodle Revision Guide. There you go. And let's go in. And this is only for people studying triple science, not combined science. So this section is only for triple science students only, not for people studying combined science and stuff. So, excuse me. So C4.5 Atom Economy, and if you're following the student book, it's pages 70 to 71. Now, the atom economy of a reaction is a measure of the amount of starting materials, which are the reactants, that end up as the desired product. That's basically what atom economy is. It's a measure of kind of how much of the starting materials, basically, is the amount of starting materials that end up, which are the reactants that end up as desired products, as the desired product. Now, to calculate the percentage atom economy, you use the following equations. The percentage atom economy is relative formula mass of desired product from the equation. So sum and divided by sum of the relative formula masses of the reactants from the equation times 100. Now, what does from the equation mean? We haven't really gone through equations that say from the equation in their formula. Well, it just means that big numbers do count. You have to use the big molar, the stoichiometric numbers, that are, the big numbers that come before the element or compound in the equation. They do count, so you have to take them into account. You might have to do, if it's like in this example, 2 lead oxide, which we're going to get onto 2 PbO, you're going to have to take the relative formula mass of PbO and then multiply it by 2. The big numbers do count. We're going to go through an example later on, but that's basically the equation. So percentage atom economy is to calculate the percentage atom economy, you use the following equation. So percentage atom economy is given by relative formula mass of desired product from the equation divided by sum of the relative formula masses of reactants from the equation times 100. And you do need to remember this equation. It's not given to you in the exam, I'm pretty sure. I don't think you get given any equations really in the exam, unless they specifically give it in the exam question, but I don't think you're given it otherwise. And the same thing is with percentage yield. You're not given these equations, and number of moles equals mass over mR. You're not given that equation as well. You have to remember them, I think. I'm pretty sure. So so then that's the equation as I mentioned before. Now, what does atom economy measure? So that's the first question of 2 in this section. So atom economy measures basically the amount of starting materials, which are reactants, that turn into that end up as the desired product. So that should be the answer, and that's what I said. That's what we've been through. So let me just see if I'm correct there. Yep, so the amount of starting materials, which are the reactants that end up as the desired product. That's correct. Good. And you just need to know that definition really. What is the it's not really a definition, but what does atom economy measure? I mean, you just need to know what atom economy is and what it measures. So it's very important actually. Kind of is a definition, but there we go. So now we move on to the next part. So it is important that to use reactions with high atom economy. With a high atom economy. These reactions are more sustainable as there are fewer natural resources. They also give fewer waste products, so there will be fewer costs for waste treatment and disposal. So this I can't really help you with much. It's just these kind of theory things you just need to know. It's very important that reactions have high atom economies, and the reason for that is because these reactions are more sustainable as there are fewer natural resources. So basically, they use fewer natural resources, because obviously the fewer resources we use, the more we conserve. The more resources we conserve. So the fewer resources we use, the better, really. And these also give less. They also give fewer waste products, because obviously if you have a high atom economy, it means you're getting a lot of desired products. So the amount of waste that is being produced, the amount of waste products being produced, is obviously reduced. So hopefully that makes sense. So there will be because of that, because of the waste products, because the amount of waste products being reduced, being minimized in high atom economy reactions. So this means that there will be fewer costs for waste treatment and disposal. So the waste that is produced, it will take, because if there's less waste, we're going to have to spend less money on basically disposing this waste and treating this waste treatment. So why are reactions with high atom economy more sustainable? So here's the second question, the last question of the section, and then there's obviously a worked example as well. Why are reactions with a high atom economy more sustainable? Well, we've just been through that. It's because they're more sustainable because they use fewer natural resources, and this means that less waste products are produced. They produce what is that? I don't know what that is there. Sorry. They produce less. Let me see. I don't know what that white thing is. Sorry, I'll take it off later. I don't know what it is. But there are less waste products produced, so there'll be so obviously if they're they're more sustainable because they use less natural resources, fewer natural resources, and they also have fewer waste products. Obviously they also give fewer waste products, and so therefore there'll be fewer costs for waste treatment and disposal. So basically what I mentioned before. I don't know what that is. Sorry guys, I don't know what it is. I'm not going to try and do that more, but I'll try and correct it later. Sorry about that, guys. I shouldn't be doing that, but there we go. Where is 4.5? Where is 4.5? I want to see the answer there. Alright, cool, just to see if I'm right. Yeah, they use fewer natural resources and give fewer waste products, so there'll be fewer costs of waste treatment and disposal. So we've just been through that. I've just been through that. Now, calculating the percentage atom economy. Now, lead can be extracted from lead oxide using carbon. The equation for the reaction is 2PbO plus C gives you 2B. Wait, let me say that again. 2PbO plus C gives you 2Pb plus CO2. So that's the equation. I'll show the working out later as well. But they normally would give you the equation in this type of question, or what they do is they tell you the reactants and products, and you need to make the equation and balance it, and then they'd ask you about it. So yeah, that's very important to know. You need to know how to balance equations, and we've been through that before, so I'm not going to go through that. But that's the equation. So it's lead oxide. Lead can be extracted from lead oxide using carbon. So lead oxide, which is 2PbO, reacts with a single 1 mole of carbon to perform 2 moles of Pb plus CO2. So that's the equation. And calculate the percentage atom economy for this process. And now we want to extract lead from lead oxide. It clearly said in the question. So that's the lead is the desired product. So obviously what we're going to do is we're going to write the equation. We know what the equation is. Percent atom economy is, so it said calculate the percent atom economy for this process. It's the relative formula mass of desired product from the equation, which is obviously the lead, divided by sum of the relative formula masses of the reactants from the equation times 100. So obviously that's 2PbO plus C. I'll just show you the equation again. So basically I'll just show you the equation here. That's the equation. So you're going to use whatever the relative formula mass of 2Pb is. You're going to divide that by all the sum of the relative formula masses of all the reactants, and the big numbers do count when you're calculating relative formula masses. And also remember that relative formula masses can be found from the periodic table. Relative atomic masses of each element can be found from the periodic table. It's the top number of the periodic table. So I've said that before. And so you're doing the MR of 2Pb divided by the MR of 2PbO plus the MR of C, and we're timesing that by 100. And remember we said 2Pb because we're not just doing Pb, we're doing 2Pb, so you count the 2 as well. We count the molar quantities as well, basically. We count stoichiometric ratios. So that's basically 2 times 207. 207 is the relative formula mass or relative atomic mass for lead, Pb. So we do 2 times that because it's 2Pb, and that's what we want to produce. That's the desired product. Divided by 2 times 207 plus 16, and then because let me just show you how they've written that. So they've written here, like, look, they've wrote 2 times, and then because it's 2PbO, so they've basically done the lead and the oxygen together, because you don't need to write 2 times 207 plus 2 times 16. You could just write it like that, 2 times 207 plus 16 in brackets, and then you add that to 12, because obviously there's a carbon as well. The relative atomic mass of carbon is 12, and remember these numbers all come from the periodic table, from the top number in the periodic table for each element, basically. And that basically gives us 414 on the top because of 2 times 207 divided by 458 on the bottom. And by the way, we times by 100 as well. It said times by 100 there. In the end you have times by 100 for percentage, so we get 414 on the top because of 2 times 207 divided by 458 on the bottom, because that's basically the reason why that is because you do 2 times 207 plus 16 and then plus 12. So if you do 207 plus 16, that gives us 223. We times that by 2, we get 446, and then we add 12, gives us 458. So 414 divided by 458 times 100 gives us an atom economy. It's quite a high atom economy of 90.4%. So that this process of extracting lead actually looks like a very efficient method. It's a very sustainable reaction because it's got quite a high atom economy. They might ask, they might ask you to compare the atom economies, and then you just work out the atom economies. They might give you the atom economies, and you might have to compare them. But obviously, the one with the high percentage atom economy would obviously be the better reaction, obviously. So that they could ask you that. But here we got 414 divided by 458 times 100, we get 90.4%, and that's basically the working out there again. If you just want to see it, there we go again. There we go. Hopefully you can see that. And study tip here is, so I'll go on the synoptic link. So topics C14.1 and C14.5 give more information about the Earth's natural resources and the impact of industrial processes on the environment. That's a long way away. We'll go to chapter 14 soon. And also to find out more about the extraction of metals, see topic C5.3. So we're going to go through that as well in chapter 5. So we're in next chapter is chapter 5, so we'll go through that in C5.3 by the extraction of metals. And then study tip here is use bullet points to summarize why high atom economies and high yields are important in industrial processes. Yeah, I can't really help you with this much. I think it's good to actually make bullet points and to summarize them and keep learning them, because these could come up as 2-3 mark questions. Why are high atom economies good? Why are high percentage yields good? And we've been through both of them, but you just need to learn them really. The calculations pretty logical here as well. You're just using relative formula masses, and then you're basically using the equation and working out the atom economy there as a percentage. And so hopefully, it's good to make bullet points, because the theory part's very important. Just remember that I can't really do much in helping you in that part, because I can help you with the calculation, but the kind of theory kind of stuff just needs to be learned, and it's very important that you learn that. So make bullet points and learn it, basically, is what my main message is there. And the key word here is just atom economy. That's the only key word in the section. And one more thing. I think in the yield of chemical reaction, I might have not done this. I've forgotten, because the keywords in that section was yield and percentage yield. I think I said that, but I'm not sure. But they were the keywords in that section. If I just missed that out, rather. And then the key points, just to finish off. It is important to so in the yield of a chemical reaction, C4.4, the keywords were yield and percentage yield. So just in case I forgot that. Now we're going on to the key points. It is important to maximize atom economy in industrial processes, to conserve the Earth's resources and minimize pollution. It helps to minimize pollution and conserve Earth's resources. And finally, the atom economy of a reaction uses its balance equation to compare the relative formula mass of the desired product with the sum of the relative formula masses of the reactants, and it's usually expressed as a percentage. And we've been through the equation. I've also been through a worked example calculation. So hopefully that makes sense, guys. Hopefully it was useful, and that's the end of the section, guys, as well. Make sure to share, like, and subscribe. And I forgot to tell you that I also have the fan on, so sorry if you could hear any noise, but it's really hot again, so that's why I had the fan on. And make sure to share, like, and subscribe. I really hope this video was helpful. Make sure to also turn on the notifications, so your notification bell on, so you're kind of notified and updated when I upload new videos that you can watch. And also, what else do I have to say? I'll try and put all the links up to the videos from C3.2 to C4.5, and also for the video also for the video I made yesterday, which was why should you pick A-level chemistry, and this is basically for year 11 students this year, picking it next month, when we go back to school. But I'll see you in the next video, guys. Next video is tomorrow. Hopefully I should be able to make a video tomorrow on C4.6, expressing concentrations. This is only a triple science topic. This one, atom economy, was only a triple science topic today. I don't think tomorrow's one is a triple science one only, but to put it in the title, I'll put TSS only for today, that it was a triple science topic. And I made the video early. I had time. I thought I'd make it now, but so I think I'll go now, guys. See you tomorrow, and thank you very much.